Okay, welcome everybody. Get this video up. Hopefully you'll watch it tonight, Sunday, December 1st for tomorrow. Let's review. Here's my unit circle. We should be pretty familiar with this. We basically pick points. Here's my 0 pi or 0 or 2 pi. As we pick points and move around the circle, we make these reference triangles where angles are related to the x-axis. Okay? As these points move around, we know from the unit circle, since the radius of this circle is 1, cosine is your adjacent over hypotenuse, or x over r, which is your radius is 1, so cosine is your x. Sine equals your y, your opposite over hypotenuse, and your hypotenuse again is your radius, and that's y over r, and your r is 1. So your sine on the unit circle is your y. As we go around, we can graph laterally on the xy type axis the values of the sine curve. Notice at 0, there is no y component. We don't even have a triangle. So we start our sine curve at 0. And this is pi halves, pi, 3 pi halves, and 2 pi. And I can go back. Here's negative pi, negative 2 pi, and here's the pi half increments, okay? Negative pi halves, negative 3 pi halves. When we start out at 0, it's 0. But notice when I start out at 0, sine is 0. And as these circles move and the triangles they make, notice the y component, the vertical component, or the sine, it gets bigger to where it maxes out at pi halves, or 90 degrees. So that's where it's 1. And here's negative 1 here. Down here, okay? And then as we come back down, notice these points as they move around the unit circle, the triangles that I make. Notice how the y value gets smaller now and comes back down towards 0 again. So sine is always 0 at 0, 2 pi, at 0 pi in any even increments, or at pi in any odd increments, like 1 pi, 3 pi, 5 pi. Okay, so here's pi. So it's 0 again here. So far our graph comes down like this. And then notice as these points move around the unit circle, again, the triangles that we make, look what happens to y. 0.5, 0.7, 0.866, and these are negative, so negative, these are all negative values, and negative 1. And that's at, this negative 1 here is at 3 pi halves. So negative 1 here. And then we come back around. Look what happens to as these points move around. Your y values get from negative 1 to negative 0.8 to negative 0.7 to negative 0.5 and so on, get smaller all the way up to 0. So here's your sine curve. And this is a periodic function, and we just keep going around this in increments. We're going to get those same values again. If I go this way, negative pi halves is negative 1, negative pi, 0, negative 3 pi halves, which is the same as pi halves, back up to 1, and then back down to 0, and this keeps going on. That's a periodic function, okay? Okay, anyway, I had to pause this, had an interruption. So anyway, here's your sine curve. Notice where it's 0, notice where it meets is it's 1 and negative 1 at pi halves. So sine is 0, 1, 0, negative 1. Now let's do our cosine. And it's real easy to make your own graph. 2 pi, pi, negative 2 pi. Here's increments of pi half. 1, negative 1. And notice the x values of our triangles. As we move around the unit circle, x is full on 1 at 0. So we start out here for cosine. We start out right here. Okay? And then as we move around, notice how x gets shorter to when it's at pi halves, my x component is 0. There is no triangle. So at pi halves, it's 0. Okay? So here, let me just draw a new unit circle here so you can see this, okay? And as we move around again, from pi halves, as these points come down, notice how the x values gets bigger till they max out again at -1 at pi. Okay? And then we keep moving around here, and notice how x starts getting smaller, these triangles, okay? So for these points, the x component here is just, notice how it's smaller and smaller horizontally from our origin, okay, all the way down to 3 pi halves. Anywhere on the north-south pole here, at pi halves or 3 pi halves, it's 0. Okay? So as I come, so at 3 pi halves, here, so it's 1, 0, -1, all the way down to 3 pi halves, it's back to 0. And as it comes up, notice how my horizontal component gets bigger and bigger until it's, you know, these points, as we make these triangles, this horizontal component, they get bigger back up to 1 again. So there's your cosine graph. So you need to know, here's your two graphs, and notice the difference, okay? Notice, very important, that this sine graph, if I take the sine graph of x and do a horizontal shift back pi halves this way, notice where these points, so, and to go left it's plus pi halves. Okay, there's my horizontal shift. It'll be a cosine graph. So we can make sine shift this. If all these points went to the left pi halves, I would have this cosine graph. If I took cosine, okay, so remember plus means left. If I took cosine and I went to the right pi halves, I would have a sine graph with a horizontal shift pi halves. Okay? Alright. Let's talk about amplitude, like 4 sine of x, or 1/2 sine of x. This affects the amplitude of the graph, okay? Remember, max minus the min divided by 2, and it's an absolute value. A -2 amplitude, the -2 just flips some graph. Instead of being like this, it's going to make it go like this and flip it. So you still have an amplitude, alright? It's the max value minus the min divided by 2, and it's always positive. The absolute value, the amplitude of this, -4 sine x, would be 4. Okay? Alright. Now let's talk about b, sine of bx, or, let me see something here, let me zoom in a little bit so you can see a little better. Okay. Sine of bx, or cosine of 4x, for example, that's your b. Sometimes you'll see it when you have a phase shift, like so, sine of 4 times x minus pi halves. Okay, and then you could have a -3 and plus 2. This is pretty much all your components. I've got amplitude, which is going to be the absolute value of that, which would be 3. My amplitude is going to be the absolute value of -3, which is 3. My b is 4. That's going to affect the period. Okay? My phase shift, C, here's B, this graph from the original sine graph is going to shift to the right pi halves, and then once we're done with all that, we'll go up or down 2. Okay? Alright. So when you take that sine graph, right here, if I change the amplitude, remember, the zeros stay the same. That's not a shift. We'll multiply all these values by, let's say, 3 or 4. The shifts will move everything. The final, this right here moves the whole graph. This moves the whole graph horizontal. This moves the whole graph vertical. Okay, and that's my D. Okay, so I've got a negative 3 sine of 4 times x minus pi halves plus 2. Amplitude's 3. This 4 affects the period. This is a phase shift left or right, in this case right, and this is up or down. This is the tricky part. The period equals 2 pi over b. So a period is what? When we go through one complete cycle of a graph. And in how much time, okay? So in this case, 2 pi over 4 means this graph just got more compact. That's 1/2 pi is now equals our period. We'll go through one whole, we're going to go through one whole cycle. Instead of doing it in 2 pi, we're going to do it in 1/2 pi. Okay, we'll talk more about that graph in the next video. Okay.